The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Thank you for joining us. My name is Brandon Ionata. I am the Director of Sales and Marketing at StrucSoft Solutions, and we are now a new member of the Grey Tech Group. As such, we wanted to present to you today one of our products. The product is called CMS for Inventor, and I'm joined here with my colleague Mahbub Rahman, who is the product owner for our CMS line of products. He'll take you through CMS for Inventor, show you just how easy it is to create DSTV NC1 files directly from the Autodesk Inventor environment, and show you some of the other features that we've built into the software. If you have any questions during the webinar, please feel free to ask in the question chat box, and someone will get back to you either during or after the webinar. All right, Mahbub, please take it away.
Thanks, Brandon. Again, everyone, my name is Mahbub Rahman. I've been helping clients worldwide with our CMS for the last 7 years, and we have changed a lot of stuff within the software, and we're excited to present you new stuff today. So let's start. As we already know in this CMS arena, that's we do have a CMS standard that can manipulate and do a correction on your existing NC1 file. Additionally, our solutions that runs on Inventor, SolidWorks, and AutoCAD, and MBS as well, that creates NC1 file from there. And then after that, if you want to do some additional manipulation, you can always go back to our CMS standard. So today we'll be focusing totally on CMS standard, which is designed to convert your single body parts to NC1. And as you see on the screen there, it can take both of your part files and your assembly files and then generate DSTV files within one single click. What is this CMS for Inventor? So it's going to read your native Inventor parts. It will read your non-native Inventor parts such as step files, your IGES files, set files, step files, and that kind of non-native Inventor platform CAD tools. It's definitely generates your .nc1 file. Our NC1 file is strictly created as part of the DSTV standard, so that's why we call it DSTV-NC1. So any machine that you work with that supports the DSTV standard will have no issue whatsoever with our NC1 file. So the fellow who are new in this area, didn't have a good exposure in the DSTV area. For those, it's a DSTV file. It's just a text files that you can open with a notepad even. Each part will have their own DSTV files. It describes your operations. It could be your external cuts, as you see. It's on the desktop here. The block will describe your external cuts. If you have any internal cuts, it will show up as an IK block. If you have any slots and drills, that will show up as a BEO block. So same goes for text stenciling and marking. So those are the main blocks that we support at this point. Additionally, we do a bending operation as well. So it just comes from if you're doing sheet metals and you have bending features, which is a KA block, we can do that as well in our CMS for Inventor solution. So what's the advantage quickly on using our solution? So it's a complete plugin. It's you don't have any system requirement for the software to use. It runs on your Inventor platform. So any system that is okay with Inventor will be okay with our CMS for Inventor solution. So you can still keep control of your user profiles, and the most usable part, I believe, in terms of licensing control is if you are going with floating options with our license, you don't need any server to host your floating licenses. So let's say you have one floating slit, you can use and install the software in multiple user machines, but you can use one machine actively once at a time, and no server required for that. So, or at the bottom, as you see, these are the sample machines currently. These are the few of a lot of CNC machines that is running our CNC files. As I said before, any CNC machines that support DSTV standard will not have any issue with our NC1 file. So without further ado, let's jump into our Inventor platform and show you some stuff from there. Okay. So so before going to the whole software, I still want to give you some idea about the NC1 file, the people who are new in this area. Okay, so as you are looking at right now in our CMS platform within the Inventor, so the software comes with a part DSTV Viewer. Okay, so as you see over here, so as I said, your DSTV is just a plain text file, and which is saved as a .NC1 extension. So the software, the part will start with an ST command and ends with an EN command, right? So and some of the properties over here that we call from this command line until this operation, which is the KA, as we mentioned, this is an external boundary description. Those lines over here that we call DSTV header data, and those lines over here, we can map data from your iProperties. The purpose why I'm showing that, before going to use your software, you're definitely going to set your settings at the first time, right? So if I go to my CMS settings and click on my property links here, as you see, I can map those data. You can choose any line you want. You can just drag and drop it over here. That's not a problem. So those lines can be mapped directly from your iProperties. Additionally, you have to have, if you want to automate your process, create your NC1 file quickly, you have to have the shape size information. So let's say for this one, as you see, I have a 4x4.25 tube that I'm working with. I have to have that information in one of my iProperties here, right? So, you can drag and drop it. So all my models over here, I'm using stock number for this information to get my shape sizes. So I'll keep it stock number as well. Okay, so going back to my DSTV again. So as you see, after description, I have 4 lines over here that is called, if you have any miter involved on your model, if I go to the right view of this, and if I just try to zoom in here, as you see over here, I have a miter. So that miter angle will show up one of those here. Okay. And additionally, going back again, so as you see, the AK is your boundaries. So you have your 4 blocks here, the reason why you are working on a tube. And then you have the BO, which is the drill operation. So you have a bunch of operations on your bottom flange, on your web, and your back web as well. So this is how it looks like on a DSTV. So let's work on a part that you want to create NC1 file from an Inventor native IPD files, right? So as you see over here, I just had a part open here. I had a cope here. I had some drills over here, and I added some slot. At the same time, I added some miter over here and some cuts on the bottom flange here. So I additionally, if I go to my my right views here and try to show you the other stuff here, I do have some marking content here. So if you want to place your welding lines, let's say you want to put a channel on that place, or if you want to do some pop marking, we can also grab those details even. So let's do and show you the process. All you have to do is open your NC1 file, and you make sure that as I said, I have to have my shape size information in one of my iProperties, right? As long as I have it, all I have to do, open that part and click on generate DSTV to get my NC1 file. So I'll just do that, and I'm expecting a window to pop up. So as you see, it's within seconds. So you significantly save a lot of your time. So, compared to other solutions that is available in the market, it's literally, within seconds, creates NC1 file. So as you see, it was able to map all the data that I wanted to have. If I don't have any data on those property lines, it will always come up as an NA. So, if you need it, so you just, you put the information if you don't have it, so it will come up as an NA. Anyhow, So if I just scroll down, as you see, I was able to capture all the details of my drills on my top flange here. And additionally, this is a slot here. So you see that? This is a slot been coming on the from your top flange actually, right? So we have multiple slots on the bottom flange here. Sorry, on the front web. As you see, I have 4 slots here. Okay, so I was talking about those marking lines and the pop marks. So there, we decided like to use a different format because you might have multiple sketches on a model, and we need to know, the software needs to know which one you want to bring as a marking line. So for that purpose, what you have to do, you have to select the line, those lines that you want to bring in as a marking content, right? So you select that and you just format that just once quickly. And the same goes for your marking content, pop marks as well, right? So the pop marks is like, your machine will go to the center point and just put a pop mark there. It's not going to do any drill operation there. So, it's just the same drill. So what do? You just highlight that sketch and format that for your pop mark. And then if you run it again, and then you're going to see like, additional information being popped up on your DSTV window. So as you see, those are the KO blocks. The KO stands for your marking lines. So as you see, I have 3 blocks because I have 3 lines here, right? Additionally, I had 4 pop marks, as you see. So those are the pop marks, as you see, shows in small m on the lines, and as well, like, I have no diameter associated to those drills. So that's why it's a pop mark. So that's it. As you see, like, it's a very straightforward tool to use to bring your copes, your slots, your any internal cut, your miter operation. At the same time, if you want to do any kind of as I said, pop marks and scribe line as well. Okay, so I want to show you another quick example on the type of what if you want to do a text stenciling, right? So you want to stamp the part, stamp the something on the part. We can do that as well. So if you keep an emboss feature, we can always create an NC1 file from there as well. So all you have to do is the same drill as I said. You open your file and you just click on Get DSTV. So and then we create the NC1 file and we give you the SI block as well. SI stands for your text stenciling. So as you see over here, that your NC1 file is being created. If I go back to my settings over here, I just wanted to notify you guys that you can always dictate your working directory, right? Where do you want to save your NC1 file? So I had that targeted on my Inventor folder. As you see, it's on drives on my drive C. Go to the folder CMS and then Inventor folder. As you see, it's grabbing, it's creating my NC1 file over here. At the same time, I have the conversion report as well. So if I have any problem with that, it will always show up on that report. Yeah, and then as you see, it grabs, for naming the part, you can either go by your part number. If you have that information on your iProperties, I can grab that detail from your iProperties and name it as the part number .nc1. Or if you don't have it, no worries. The software will automatically move on to the document name. Okay, so as you see, the document name of this one was something different than the part number, right? So the part number was just a 3A. So that's why I just saved this as a 3A.nc1, not the full name ad that you see. So over here, as you see, you have full control over naming as well, right? So yeah. So additionally, like for stamping, if you don't want to do like embossing, for example, and you want to bring your a sample details all the time on a given face. Let's say what I'm trying to say over here is this. So let's say you don't want to draw your emboss feature on a part, but you want to bring the part number, for example, as a stamping content on that. So you can always do that. So I can just do that. I can create a stamp and I can dictate where do you want to see that. So I can just give it a default position. So let's say I want to put it on my front face, okay, on the front web, okay, and I can go to like from the top right from the top left corner from 2 inches and then 2 inches on y opposite direction. So, and the size of the text as well. So additionally, what it will do, it will read my part name. Okay, so if I go back to my property link here, as you see for the part number, it will grab the part number and put it as a default stamping. Again, gentlemen, and then it's only time you will need it if you want to do a stamping, right? And a default stamping with the part number with the default positioning. Okay, you can also dictate that the position if you want to do that in millimeter as well. So the default is in inches. So I'll just do that, and I'll just say save and exit, and I will rerun that. The same conversion of that part. So I will run it, and I'm expecting a default SI block as you see over here. So as you see, it's position is putting in as you see, it's a 50.8 millimeter, so which is 2 inches, and it gives me the content of my part name. Okay, so you know if you just go to our website, and you will find that we do have a viewer, a free CMS viewer that you can see your created NC1 files. So what I'm going to be doing, I'm just going to be showing you just a quick idea how things looks in the CMS viewer. So if I just copy the path where I'm saving my NC1 file, copy that and bring it to the path over here, and it will list all the NC1 file that I just created. So if I just go my front web view, as you see, this is my NC1. Well, as you see, it's just coming out of this boundary here. It's just a viewer issue. It's not a big deal. So if I just come over here, you know, things might overlap, so you can reposition that all the time. So I just wanted to show you over here. As you see, those are the things that we put on that channel. There's the marking content that coming as a line, scribe line, and those are my pop marks. Okay, so you can use that tool to verify your output quickly as well. So all that this free viewer does, you know, you can open your NC1 file and visually verify that. Okay, so going back to my Inventor platform and we'll work on a different type of models as well. So I'm just going to open a channel here. As you see, I have some what do you call it? It's a miter over here and some cuts on the other side. And the drill is same, you know, as all you have to do is just open that part and click on generate DSTV. Okay, so I'll just see it on there. So right away, there's NC1 file that gets created, and I get the miter angle here as well, as you see over here. I get all the details, including my my default positioning of the SI, which is the text stenciling. It reads my shapes, my part number, and paste it over here. Okay. The same drill, you know, it could be, you know, I have shown you all the examples with external cuts and boundaries on the boundaries, but if you have any internal opening as well, that's not a problem as well. It's just same drill. You know, as many opening E1, it will just create those IK blocks. So IK stands for your internal cuts. So if you just click on there again, so if you just scroll down, as you see that you have your IK blocks being created, which is for the opening. Right, so if I just want to verify that the new NC1 file over there, I'm just going to refresh that path and go to that new beam here that I created. So as you see, that's the size here, you know, that's just tapping of the part, and then those are the opening that we just created, right? So it's pretty straightforward. Like, you know, for any kind of you know, coping, could be a co-fillet, could be regular coping as well. So the drill is exactly the same as we told before. It's just a one single click to create your NC1 file, right? Same goes for your angle as well. As you see, I just added some of the opening inside on the both legs, and the drill is again the same. That you click on part DSTV to create your NC1 file. So going back to the viewer just to see the changes on the new new parts we just created there. So as you see over here, that's the part we just created so if I just go in here, as you see, I was able to grab the cart here. So as you see, the text, the size of the text on the viewer is big. That not necessarily tells you that's going to be your final output, right? So going back to my other examples here. So the drill is same for your angles with drills, in equal angle. We'll grab your sizes information, as I said before, from your stock number. It could be anywhere, not necessarily stock number. I am following stock number, so it could be in your description or in your material, whatever you want. So same drill, create the NC1 file from there. Okay. The drill is same for the tubes as well. So you open your tube and create NC1 file for there. Okay, so that's about creating NC1 file from your parts. Okay, what if you want to do and create your NC1 file from an assembly or something? Okay, so I'm just going to work with that assembly file here. Okay, so as you see, over here, a bunch of parts over here. Okay, to automate your process, you have to keep few points on your mind. So the first thing that you have to have that we have to follow an approach that we call call-I approach. Okay, so I'm just going to go to my one of my PDF here that I call requirement for automation when it comes to your converting your assemblies, right? I need to have the shape size information. You have to make sure that you have it on your I properties, right? If you don't have it, well, you can always match it through our CMS shape catalog, or you can add a quick add tab, that information. Remember, we are trying to batch process everything, right? So we have to have that information beforehand, before running the command to create NC1 file directly from your assemblies. So I need this one. The first thing is I need the shape sizes. After that, I have to have an sketch planes and profile planes, whatever it is you call it. Like I want to have them placed that what we call is call-I approach. So that means when you are in your front plane, I want your channel sketches look like a C. Okay, so the same goes for your tubes. Okay, so if you're working on your tubes, it have to be standing with the long hand. If you're working on a long rectangular one, it have to be the long hand have to be standing. The same goes for your unequal angle. The long hand should be standing, and the thing goes for your I-beam should look like an eye on the front face, right? And if you're working on a plate or a flat bar, especially, it's on flat bar. If you're bringing, remember, it's a shape. Flat bar is a shape, but plate is not a shape, right? So plate, will treat it as a plate. But if you want to bring it as a flat bar, your flat bar need to be standing on the thickness. Okay, so as you see, it's look like an eye. So that's the reason why we just call it call-I approach. So again, that have to be done beforehand to convert your assemblies to NC1 file. Okay, so the software comes with a couple of options. As you see over here, you can tag part. You can select parts and tag it. Let's say you want to process your channels first, and then you want to process your angles. You can always do that, or you can just select few members, right? And then create NC1 file from there, or you can just run the entire assembly. So I'm just going to run the entire assembly here. So what happens is, like when I'm click on this, I'm expecting the software will kick in and create NC1 file. At the same time, it gives me a report as well. So if I just open that report, it will list if I have the software missed anything. So the only part it skipped was that part. See that? So this is very helpful, right? So you create your batch process your part, and additionally, it gives you a clue what was the issue there. So for some reason, that part was skipped, and it gives you an area as well, because it was trying to calculate the area, and it found the area to 0. Okay, and then the part was skipped. So if I just go to that part, for example, so I see this is a plate 03. So if I just go to plate 03, where is it? Just bear with me. Plate 03, plate 03. Maybe hiding somewhere. I guess this one is plate 02. Maybe the name, the part name was wrong. Maybe, who knows? So if I just go to the I properties, no, it's 02. So you always can figure out like which one is not working. So I can just you figure out that and work on it. So I wanted to locate that part, but unfortunately I can get it done. Let me try it again. 0303. I don't see it here. It's only plate 02. Okay. Anyhow, so we can there is always a way to work on it. I'm looking at that error. I easily know what the reason is. It's like it didn't match with the Kali approach. So the part was not positioned as the software was expecting. So you can always go ahead and we can play with that. So in my coming examples, I will show you what happens if things are not being placed as expected. Okay, so we'll talk about it. Anyhow, but if you grab that new path over here and copy that and go back to my CMS viewer, and you can actually quickly verify all the parts you just created, right? So as you see, by default, it's been placing your shape size, the part number as well on those each and every parts, including the plates. So this is a plate, as you see. The other plate, this one here, this is a tube. So everything was grabbed quickly and was created in NC1 file, right? So let's go to another example and see other way of doing stuff in an assembly. So as I mentioned, you can also select members to create NC1 files. So let's say for this example, I can just go ahead and select the members that I want to create NC1 files. So if I just go some quick selection here and there, I can always do that with this. So let's say go here and there, few parts, and this one here. Okay, and then I can just go ahead and do that. See that over here? It's called DSTV for the selected items. So I can just go ahead and do that, and the software will process them and create a folder exactly the same name as my assembly name, and give me all the NC1 files with a conversion report as well. So if I don't have any error, that report will be empty. So as you see, in all the files that I have selected, I was able to create NC1 file from there. So I copy that again, and I want to show you that those produce NC1 file quickly. So as you see, that's my first beam here. You can always zoom in, zoom out. You'll see verify this the NC1s. It was able to grab all the details. As you see, I was able to coax an opening. So all the details was coming all correct. So if you just go to the front web view, as you see, those are the stamping of the part number. So everything was batch processed. So the last thing that I want to show you is on a small example, as this one here. If you want to tag anything, this is a very tiny part, but if you want to tag it to work on the tag part, you always have to make sure you're working on an assembly that is doesn't have any link issues, right? There is no missing link. So and then you can work from there. So if I tag one or two parts, I just want to tag, I don't want to create plate, I just want to create shapes, right? So I can just tag select these two and tag them, and and then I can just create the NC1 file from there. As you see, it just creates the parts that was tagged, right? So and then tagging could be done by your convenience, for your convenience, whatever you want to achieve with that. Okay, so that's pretty much it about processing your assemblies. So again, to sum her up, to work on an assembly, you have to make sure that you have your shape size information present on your iProperties and your part number. Okay, and additionally that you make sure that you are following the Kali approach that we expect to process your assembly files. Now I want to work on, I want to show you some of the stuff that we have done with sheet metal. So we didn't support sheet metal before, but at this point we can support sheet metals, and additionally, as I said, we do support your bending operations. So as you see, this is a beam being created from a sheet metal, right? So if I just go to the flat pattern, as you see, this is a flat pattern, right? And I can just go back to the folded part. So you don't have to do, all you have to do, you have to open your part again. And it's a flat pattern. I mean, it's a sheet metal, so there is no size issue. So you don't have to give any sizes. So all you have to do is generate DSTV for this. So all it does, it will create NC1 file and will give you the bending details as well. So as you see, I get a plate which is a 3mm thickness, and I have all the drill been listed here. As you see, I have a bunch of drills, and I stamp on a default position my part number. At the same time, those are the KA operation, which is the bending. So it gives you all the bending operations that have been done on the whole part. Okay, so it's super powerful. And this is really something that you can use and save a lot of your time. So I'm just going to show you another example of different other example over here. As you see, I had another one. If I go to the flat pattern, just to show you guys that not necessarily your flat pattern have to be on. I'm just going to go back here. Not necessarily have to be horizontal. We can also work on vertical ones. So if something is done on vertically, no issues at all. We do the same stuff. So we come here, and you open your part and click on Generate DSTV, and then we wait for the response over here, right? So did I do that? I think I did. Yeah. So it's the same part. Yeah, that's the example 5. As you see, there's example 5. So we're working on example 5. I was able to grab all those operations, right? So if you want to see those on our viewer, the viewer will not show you the bending operations. So if you have any CNC machine does support the scale blocks, you will be able to see that there. So if I just try to open that on my viewer over here again, so I go and copy the path. It's not in my mezzanine anymore. It's going to be ending up on my regular one. And as you see, that will CMS will out those operations here, because it cannot show you the bending operations. So it's going to show up, as you see, that my example 7 was a flat pattern with bunch of drills. So as you see, it will list it up, and if you want to do the stamping, that will show up here as well. So it's pretty easy to use for your sheet metals. Saves a lot of your time. Now, I want to show you some of the stuff. What if, you have something that is non-inventor CAD what do you call it? CAD extension, like step files or set files or IGES. So that's pretty straightforward. I'm just going to close all those here just to save some quick opening problems. I'm just going to close them all quickly. You know what? I can just say close all. Just bear with me. I don't want to save it. Okay. Nope. Okay, so also this is a part of the sheet metal that I didn't show you guys. Also, if you use sheet metal to create your profiles as well, all you have to do is make sure that your things are designed as our expectation. Remember that we said we want to see your anything that you draw that have to meet the Collai approach, right? So this is a sheet metal, but as you see, we don't want to bring it as a sheet metal, not as a plate, but we want to bring this one as as an angle, for example, right? So what I have to do for those cases, I have to go back to my CMS. I have to do the settings. Right now, you're not on a standard platform, right? So you go to your processing, and for the set orientation, you have to come back to your custom orientation. So you just not necessarily going to use the default orientation plane. So you're going to be defining them. So that's pretty easy. All you have to do, you come to that plane that you want to set as an orientation, and you click on that. So take a look here. So it's a right face and kind of tilted, right? The second that you click on set orientation, it will become your front face. And then you need the shape size information, right? So either you have to have it on your properties, right, somewhere, or you can use our quick tool, as I said. So this is a good example that we can use to show you how actually this quick tool works. So I can just type it in from here, or if you don't want to type it in, you can always use our CMS library. So this comes with with all the part sizes. So let's say we're looking for an angle. And if you just scroll down, as you see, those are the values of height and width. They're in millimeters. So if you want to see them in inches, so you can always do that. And I know that's the shape size that we are working on here. So this is a 2 by 2.5 and 2.5 with 3/16. So you can just double click here, and the software will take that size for that. And then you just create generate DSTV, and boom, right away you have the NC1 file. See that? And then if I just try to see that NC1 file on my viewer, copy that. Remember, this is not a plate, It's a shape right now. See that? So if I just go to the front web view, it's just it's a default position. That's why it's coming out. It's because it's a 2.5 and 2.5, right? And the two referencing was too much for it. So you can always edit that, or you can just get rid of that. You know what? Let me do that. Remove that default stamping, and I rerun that. I'm just gonna remove that SI block from there. So if I just refresh that, that SI block will be gone, and this is an angle that we just created from the sheet metal, right? So so that means we can read your sheet metal as a plate and also as a shape, And for those ones, you have to manually set your orientation if you are not initially designing it as per our COLI approach. Okay, so let's work on some of the step files or IGES files that we mentioned. So I'm just going to go and close all these windows here and grab some of the step files. I will just start with the sample one. I open that. As you see, this is an very basic Inventor process. So it runs and save it as an IPD right away. And I want to go and change the view just to show you guys what's there. So as you see, it's a tube with a huge number of not huge, but few drills here and there, right? So all we have to do is make sure that we have the shape size information here, right? So I'm going to go back to the properties. I'm going to see status, or okay, I have that information, but it's not on my stock number, right? So I can always use that quick tab, right? So I can just do that here quickly. So I'm going to type it in just to show you a different way of doing stuff. So it's a 4x4 and then quarter. So if you just enter from your keyboard, it will take the size. And then, as I said, you can always set that orientation from here and click on Generate DSTV, and it will update your NC1 file over here. As you see, it created all the NC1 file, listed all the opening, and also all the drills that we have, all the faces here. So if I just try to see that over here, all I have to do is refresh that, and I know this is sample.nc1, and as you see, I was able to grab all those drills over here on the front web. We are getting all those details from the step. And remember, this is a solid body. We don't have any information whatsoever, but our software was intelligent enough to grab all those all those drill operations. Initially, we had to run the feature recognition tool within the Inventor, and we actually get rid of those that step. So you really save a lot of time over here to process your step files. So the same goes for your IGES files as well. So if I just drag any IGES, by the way, we can also work on imperial shape as well. So this is an example of an imperial shape, as you see over here. So it's the same drill. You just if you don't have that information, the size information over here, you have to give that manually. So it's a 200 PFC. And then you just press enter from your keyboard. If you want to quickly set this orientation and hit DSTV, and then right away you have the NC1 file over here. Okay, so if I just want to see the same NC1 file just been created, I'm just going to refresh that. It's always better to verify your NC1 file every time you create that. So your best bet would be process all the NC1 file first, and then come to the viewer and verify each and every one, right? So as you see, I was able to capture all those cuts and the drills with no issue at all. Okay, so it's very smooth operations here. So the same goes, the process is very similar for the other formats as well. So if I just try to open a SAT file here, it's the same thing. So if you open your SAT file, it's trying to open it as a multi-body part. I'm going to say okay anyway. I'm going to say okay. So as you see, it comes to opens it and save it as an IPD file, right? So all you have to do is just give it the shape size information, because it doesn't have it, right? So I have it, so it's 60, enter on the keyboard, takes it, generate DSTV, and it updates the NC1 file. As you see, it grabs all the details on the drills. So if I just try to verify that again, refresh that path to see the updated NC1 files here. So it should be over here. There you go. So as you see, it was able to grab all those drills without within seconds. and I would say it's pretty powerful for sure. Yeah, so that pretty much it in terms of your non-native Inventor contents. So additionally, what we have, we are developing and in the process, and we have gone almost 80%, is we can read your pipe as well. So if you have to work on pipes, we can do that as well. So at this point, I'm going to be working on a very simple pipe here. So the process is very similar, as you just have to match it with the size that is within the library, or if you don't have it, you can always edit and create something that you want. So as you see over here, I went to the edit and I can create a pipe which is custom size. You can always create members from this window. So it's so it gives you an option to work on custom sizes as well. Remember, it's a custom size, not custom types. We still stick with the standard profile types: your channels, your angles, your beams, your tubes, and round profiles. Those kind of standard ones. Unfortunately we don't support the Z profiles at this point, but we'll eventually go there. But if you create the Z from your sheet metal, we can easily grab it, right? Without any issue. So let's go and work on this. All I have to do is I have to know the size. Just gonna verify that quickly. Well, I do have the size here. As you see, it's a pipe 1S. All I have to do is set this orientation quickly, because I'm using a custom orientation. Remember that the last time that I changed to my set orientation to custom, so that's the reason why I have to additionally click on set orientation. But if you have it set to a default front plane, you don't have to do that. So all you do you just open your part and click on DSTV, and voila, your NC1 file is good to go. And that's pretty much it that I wanted to show you today. Thank you, gentlemen, for your valuable time.
Thank you, Mahbub, for showing us all of that. Of course, if there's any questions, or if you'd like to get more information regarding the software, please reach out to your local Graytech sales representative. They'll be able to put you in touch and get you the information you require. So that concludes our webinar today. If you'd like, there will be a recording posted later on of the webinar that will be shareable for anybody that wasn't able to make it this afternoon. Thank you, Mahbub, once again, and thank you for everyone that joined us.
Thanks, everyone.
Have a great day.